Alright, silly people, here's the situation. We're in the particle in a box again, and we're going to be checking that the expectation value for the energy that Griffiths gets is the right one by calculating it the old fashioned way. Um, that is the expectation value of the energy for the wave function that he got in 2.2, which was um, the square root of 30 over a to the fifth times x times a minus x. Um, and the Hamiltonian for the particle of the box is the simplest Hamiltonian you can get. What makes the box special is the boundary conditions. So it's just the h bar squared over 2m d squared dx squared, or in other words, just the kinetic energy operator. Um, so, I mean, that's what we're going to do. It's going to be fairly straightforward. Um, I'm going to go ahead and pull out the prefactors. You're going to have a 30 over a to the fifth. You're going to have a minus h bar squared over 2m. And then in here, we're going to have x a to a x times a minus x. And then we have d squared dx squared of x a minus x dx. And that's from 0 to a for the box. So just going through the motions, gotta do the derivative in a second. Whoops. X a minus x. First derivative is going to look like a minus x minus x. So a minus 2x. Okay. I'll just rewrite it like that. Integral from 0 to a x times the first derivative of a minus 2x dx, which is just going to be minus 2, right? So I'm going to actually factor out a minus and the 2 and just have 30h bar squared over ma to the fifth out here. And then in here we got just x a minus x now. Integrals are not too tough, but I am going to expand it into a times x dx minus x squared dx from 0 to a, which does evaluate to we got ax squared over 2 minus a x cubed, not even an a, just x cubed over 3. You got 0 to a, and that's plugging in the endpoints. We got a cubed over 2 minus a cubed over 3. Factoring out an a cubed, we'll have ma squared on the bottom. And then it's 1 half minus 3 minus 1/3. So 3/6 minus 2/6, so 1/6. So it's, yeah, 1/6. Which looks like 5h bar squared over ma squared. And that is what Griffiths got, so checks out. Nice.